Alright, this is Chunk 1, Module 4. We are using the scanner objects to get user input, and we are manipulating that input with if statements or control blocks. The purpose of this video is to give you an overview of the key concepts that we'll develop in this module. I'll ask you to follow along with me on technologyrediscovery.net, and I'll show you how to get there. From our homepage at technologyrediscovery.net, we click the link for Chunk 1, Module 4, Input and Control of Flow. So here we are. The image that you see at the top of the page is Nedfree. Nedfree is no longer with us, but Nedfree was my first and most rigorously used vehicle. You see a picture of Nedfree marooned in southern Utah. The reason I put this up is because a lot of the activities that we'll work on in this module relate to cars. I like cars. And if you're curious and you have a little downtime, you can see a couple of the other photographs of me and Nedfree. This is me when I had my first teaching job in East Central Arkansas. That is a soybean field. That's where I live. That's my front yard. And this is everything that I owned at the time. And I'm ready to roll, ready to get out of Arkansas. Nedfree took lots of trips with me in southern Utah to go canyoneering. This is Nedfree at the edge of a massive canyon in southern Utah, and Nedfree actually supported me. That's me down here, way down there on this rope, and the thing that's keeping me from falling to my death is Nedfree's weight as acted upon by the force of gravity. Nedfree was also a moving van, and when Nedfree went to the grave, the odometer read 284,411 miles, and I changed his oil regularly. So the reason I put the car up there is because I want to speak conceptually about what it is that we're doing in some of these Java programs. I want to give you the higher level picture of where this goes, and then I'll actually walk you through the nitty-gritty of how the code works. So let's review our learning objectives for this module. We're going to use a scanner object, which will help us get user input from the keyboard and convert it into values that our Java source code can act on. The second objective is that I'd like you to be able to implement basic logic that decides, or you put in conditions in which the program evaluates and can evaluate or decide which chunk of code will need to be executed based on the result of a test. Setting up your workspace is important. Let's make ourselves a package called week 4. Remember, anything that's not a class name needs to begin with a lowercase letter. So this helps us read Java code fluently. If we see a capital letter, it's a Java class. If it's not, it's something else. It's a variable, it's a package, it could be all sorts of things. But in this case, the package name week 4 has lowercase w, and then the class files that we'll make inside of that package are all uppercase start words. Okay? Once we've got that all cooked up and ready to go, we are down here on module core concepts. Let's give you a little review of how I think you should be using these videos. This is a concept that I'm going to call the work along concept. There it is, the work along concept, which means I don't think it's very productive for you to pull this video up and just watch it from beginning to end. It's great that you're watching me now, but what I'd like you to do is position your workspace so that you can see me in the video and your NetBeans workspace, potentially even also our source code. So if I've got NetBeans here, most programs, Windows and Linux alike, allow you to drag windows. See how I did that? I grabbed the navigation, or I grabbed the window bar at the top of NetBeans, and I actually moved my mouse so it touched the left side of my screen. That chopped the window in half. Windows will actually give you a chance to just click the other possible window to make the right hand of your screen. But I have to select it by hand. So if this is technology rediscovery and I'm interested in running a video, I can pull that up, or the source code from the modules, or Oracle, or your textbook on the right hand side. So with that set up, this allows you to work along with me as I go through this code. So please make sure that you are setting up your work environment to be the best possible way for you to learn and get feedback about what's going on in the code in real time. I'm going to begin discussing scanner objects concretely. Please read the text. I am summarizing it here in this video. We are going to run this program. This program lives inside of a class called user_input. And inside this class user_input, we have a main method. This is the method declaration. This tells the compiler this is the main method. It's called main. We also have keywords that give the compiler instructions for how this method is supposed to function in the program. Alright, let's pull up NetBeans. So let's fire this up. We have a class called user_input. If you read the comment at the top, it says this is a class to demonstrate the functionality of a scanner object to get input from the user. In this case, the problem that this program is trying to solve is that we want to calculate the final sale price of an item, the price of the item plus the sales tax to give us a total price. This is a useful problem to solve because I may not necessarily know what the price is that I need to calculate the sales tax on. So the program solves the problem of, if I don't know what the price is, can I create a system for taking that price in, doing some math on it, and then outputting the final sale price. That's a problem. Java can solve it. And let's see how it actually goes about doing that. So let's run the program. I did a Shift F6, and here's my output. And it says enter the sale price, no $sign, and press enter. So I'm going to do that. So let's say I bought a $34.20 item. You'll see that after pressing enter, the program outputs your item price plus 7% tax is $36.59. And because we were working with a double type variable that I have not formatted or trimmed to only have 2 decimal places, we get a long output because the 7% of $34.20 is a long decimal number. So let's look at our core concepts and think theoretically about what's going on. If we review the code, we've got a main method. We have a final variable to store the tax rate. And I declare some double type variables. Okay, let's get set up here. Let's draw some pictures. So we've got a problem. Let's erase work along here. I know you're working along with me. That's great. One of the core concepts that we will develop here in Module 4 is to think first. It's a common pattern among new programmers to think that the programming process begins and ends with Java code. That is a woefully inaccurate description of what programming involves. We want to think about the structure of our solution to a problem, and when that is secure and solid, then we translate it into Java code. So let's think high level of what our program for sales tax is doing. We want to get some sort of input, and we're going to capture that input in a variable of type double. That means a number with a decimal place. We are going to give that piece of data a name, so we can refer to it by name. So sale price, we're going to create this variable. We have to tell Java what type of data is going to be stored in this variable. In our case, we're saying whatever number goes in here, I need you to treat it like a double. That means a number with a decimal place. We don't know what's in it. It's variable. It can have any double value within the limits of the Java programming language. So if we think about it, I want to take in a sale price, and from that sale price, I want to add a 7% tax. So I need to do something like sale price, and I know I need to multiply it by a tax rate. So if I want to get the sale price and then add 7%, effectively I can do that with multiplication by 1.07. The 07 is our decimal version of 7%. and the 1 captures the entire initial sale price and adds that 0.7% on top of it. This together we want to capture. And whatever that answer is, we want to output to the user. More importantly, in order to output it to the user, we want to store it in a variable that has the name price with tax. That's also going to be a double value. This is what I'm going to output to the user. I just made a very simple flowchart. So we could think of this as an input. We can think of this as the output of our program. And now, if I feel good about that, I take some sale price in, I manipulate it with an operator, in this case multiplication. I store the value in a new variable, price with tax, and then I can do whatever I want with it. I can print it to console, which is what we'll do, or print to screen. Console is a word for that output window that has only text. You can't put images in there, you can't make the text pretty, you can't make it bold, you can't make it green, it just prints out text. If I can print it to the screen, Java's cool because I could write it to a database, or send it up to the web somewhere, or send it to a text message. Output could be determined after we have something to put out. That's our overview. Let's see how that's actually implemented in the program. What we're going to look at in this situation, unlike last week we actually coded in this. I told you to initiate a variable and then we would put in a number like sale price of $33.11. We say hard-coded because we actually typed this number into the code itself and then compiled it. There was no way to change this value during runtime. That's not very useful in the programming world because the value of a program is that we don't necessarily know when we're programming it what the input will be. We want to make a tool that can work with any input. So how are we going to get our sale price into the program and then multiply it by 1.07 and spit it back out? We do that by using a tool that's part of the Java library. The Java library is like a library of paper books. It's written by someone else, it's organized in a systematic way. We can look up the chunk of code, or in this case the class file that we want to use in our program, and then we can use an import statement at the top of our class file to import the program, or excuse me, to import the class file. In our case, we are going to import a scanner object, and that scanner is located in the Java. That's not very nice writing. The java.util for utilities section, and then we have a scanner. Okay, I'm going to adjust this diagram a little bit so that we can see how this goes. Now, it turns out with computers, it's actually not, we would say it's a non-trivial issue to figure out how to turn the keys pressed on the keyboard into a single number. We have to figure out where that keyboard is. Remember, Java is a cross-platform programming language. It can run on computers that have a touch screen. It can run on computers that take audio input from someone who is vision impaired and convert it into data that the Java program can work with. We don't want to have to deal with that. As individual new programmers, we want to type numbers on the keyboard and get it into our variable of type double called sale price. So the more that we can use existing code that is designed to do just that, the faster we can produce programs that solve the problems that are important to us. In order to do that, the structure in Java is that we create an object. That means that we allocate a chunk of space in memory for a set of code that has methods and member variables that will help us do things. I made a nice diagram. If we pull it up on our screen here, we are still recording, which is great. Here is the lovely diagram that I made that I will actually not try to reproduce on the whiteboard, because I'm out of space. I have recreated the user input class. So this is what we've written. We have this magic line here. Let's go back to the actual source code. Once we have declared our variables, we've got sale price, meaning this can store double value. We have price with tax. That's what we're going to fill up with our calculated total cost. And then I also have what's called a final variable. And some of you who are keen would think, that's an oxymoron. If it's variable, it changes. If it's final, it's not changing. We say it's a final variable because it will not change in our program. We are making it fixed. This is helpful because it avoids errors of accidentally changing a value that we don't want to change. When we declare a variable final, we write the name of that variable in all capital letters and delimit the words with an underscore. This allows programmers to see I'm not going to be multiplying something and storing it in that value. I'm going to use it and I'm not going to change it. With those all set up, okay, I've cleaned up the board a bit. We are sitting here at this line 36. The comment to this line is creates a scanner object using the imported class library. Let's dissect this line. When I scan it, what do I see? I see, okay, I have an equal sign, which is the assignment operator. That's different than an equality test. That's double equals. What this is saying is take whatever's on the right and store it in the thing on the left. That's the basic structure of any assignment statement. It uses the equal sign, which is an assignment operator. It operates on two values, the value on the right and the value on the left. So what do the words on the right mean? It says new scanner, parentheses, system.in, close parentheses, end statement. The new keyword is critical here. What new is saying is go to the class library that you downloaded with your Java virtual machine and find me the scanner book. The scanner book will tell you how to make me a new scanner object, stored in memory. Now I have to be able to get that object out of memory when I want to do something with it. In this case, I want to scan whatever the user typed on the keyboard and I want to read it into my program. So the new scanner, system.in, is the statement that says, go make me a new scanner. The system.in means that scanner knows how to go to the keyboard. We have keyboard down here. That's in the diagram. Scanner objects know how to go to the keyboard, get a value, and then we can store that in sale price, which is a variable that accepts values that are doubles. So we are working with our assignment, which is go make a scanner. As of that line, the scanner's just chilling. It's down there in memory. It hasn't done anything yet. We've simply instructed the compiler to get ready for us to use the scanner object. Now we have this thing on the left, scanner, user input scanner. So the word scanner, capital, that's a type. So what we're saying is, I'm going to make a variable. It's just like this. It's just like making a variable that stores a number with a decimal point. But this is object-oriented programming. When the early days of computers, you spent most of your time just with numbers and text and you moved them around. But in Java, we can have entire objects that live in a variable. Now they actually live in memory, and we use a variable that we can name whatever we want to point to that object in memory. So the fact that scanner is capitalized means we are declaring that a variable of the name user input scanner will only contain, in this case the Java term is a reference to or a pointer to a scanner object in memory. Now I want to prove to you, you should prove to yourself, the compiler doesn't care what we call the pointer to the scanner object. It cares that it's a scanner object. Scanner is a specific type of functional entity, an object in Java. But the name of our reference or our pointer variable, user input scanner, can be anything. So for example, we can rename variables. So I could say, this is Zan's user input scanner. That's my nickname. So Zan's user input scanner. I can change this to whatever I want. It just is the way that I'm accessing it. Okay. Now we'll see that in the code it flagged this, the use of the scanner. So notice this says cannot find symbol. So after I prompt the user and tell the user to enter the sale price and then press enter, don't use a $sign, I'm at line 41, which is another assignment statement. The reason the user input scanner is flagged is because I'm storing a scanner in a variable called Zan's user input scanner, and it doesn't know about any variable called user input scanner. So I'd have to change these to be the same. Okay, so I can use my brand new scanner object. I can use the small but mighty. This is the dot. The period is the access operator. What this says is, find me the scanner object that's pointed to by user input scanner. Use the next double method. So the dot is accessing the next double method. Next double method is a thing that the scanner does. It gets data and converts it into a double type, meaning a number with a decimal point. And then once that's done, that's the right side of the assignment statement, store it in whatever the container is on the left. In this case, it's sale price. Now, we haven't run the program. Well, we did run the program, but when we're writing the shell of the program, when we're writing the code structure, we are simply saying whatever the scanner gives you, could be anything that's allowed, put it in sale price. And the sale price is allowed to accept type doubles. That is concluding line 41. Now, once we have a sale price, so let's give this some concrete value. So let's imagine that the user entered, let's see if I can get, maybe red will show up. So let's say it is a $3.51 candy, monster drink, because it's in the middle of the night when you're doing Java. And that variable sale price now contains the value 351. So when we're looking here at line 43, we have another assignment statement. Start on the right hand side. Ignore the left. The compiler is going to make sure that it can evaluate everything on the right side of this assignment operator and boil it down to something that can be stored in whatever the type is on the left. So in this case, the compiler says, they're going to be storing it in a double type. So everything on the right has to come down to a double value. So the instruction on the right is look up whatever's in sale price, multiply it, this is our multiplication operator, multiply it by the quantity 1 plus whatever the sales tax constant is. In our case, it's 0.07. So it does this math. This is normal math from math class. This becomes 1.07. It multiplies it by 3.51 and then stores the result in price with sale tax. So when line 43 is done, we have a variable price with sales tax that contains whatever this value is, 351 times 1.07. It contains 37557. This storage in price with sales tax happens only after all of this is evaluated to 3.7557. And the last line of our program, meaning the last thing that the program does before the main method ends, is send some value to the printline method. Again, this is our access operator. The system object knows how to send data to the screen with the help of the out object. We are accessing its printline method. Methods do things. What does it do? It prints out whatever's in these parentheses. I want it to take the literal string, your item price plus 7% tax, colon, space, $, and then squish right up next to it price with sales tax. So go look up price with sales tax. Now in Java, operators sometimes use different operators, sometimes use the same symbol. So we have equal sign is always the assignment operator. It never does anything but takes what's on the right and stores it on the left. The plus sign, however, has two jobs. It can function as an addition operator. Take a numeric value on left and right and add them together and give me the result. In the case of line 45, because we are dealing with text or string values, when I use the plus sign here, it is the concatenation operator. Concatenation is a fancy word for squish it together. Squish together the literal text, your item price plus 7% tax, colon space dollar sign, and squish it up with whatever the looked up value is here. So when we look at our output, once again, we can see that's exactly what comes out. Your item price plus 7% sales tax, that's our literal, and then the calculated value on the right. You can see that I put that dollar sign in. That dollar sign is not part of the double value. Double values are not unique to currency. They are just a number with a decimal point. So we have to, if we want a nice, pretty looking output, we put that dollar sign in ourselves. So the result comes out with something that looks nice and tidy and is easily interpretable by the user. Whew! Okay, that's your first program. Let's just review what's going to happen with the remainder of this module. So it gives you explanation. I put in some nice boxes for you. I also go through how to work with the fact that sometimes if we are entering data that is not convertible, so if I run this again, let's zoom in and I say, it says enter the sale price. Let's try this. Let's say I try to type in $3.51, let's say $3.51. This is interesting. Look at this output. So I thought it was going to get upset with me and say you have an input mismatch, that it can't convert the word dollars to a double value. What it actually did, the reason the program succeeded, is the scanner is only taking the first value until the first space and converting that into a double, and it can convert a 3 to a double. It just adds a period and some zeros after it. But let's try this one more time. If I enter $3, no space, I get an exception. It says input mismatch exception, which means if I give the scanner object, what did I give it? I gave it 3 and then the characters, it goes, and I can't fit, I don't know how to turn character D, character O, character L, L, A, R, S. I don't know how to turn that into a value of type double. It's strongly typed language. Java is going to enforce that whatever we store in sale price has to be of type double, or it will give us an error like this. We can implement logic to check the value before we try to throw it in a double value or double variable, and then we can ask the user for a new value, but that takes more code. The point is, this will always hold true. It's a not very graceful thing to have happen to a user to get this error message and the program ends. I did that to demonstrate. Strongly typed languages will only allow a variable of the declared type to be stored in that particular variable. I'm going to ask you to type in and execute every chunk of code in this module. It's important for you to get the hang of how Java flows. So that would involve having the source code up. You can have source code on the left, and then open your new class file, have NetBeans on, or it doesn't matter which side. Have them both open on the screen at the same time so that you can transfer the code nicely over and read the comments, please. They will refresh in your brain what these individual lines of code are actually doing. So with that, I'm going to ask you to continue working through Module 4, and I will be coming back online to give you some tips and some programming screenshots as we go through. So enjoy.